One of my viewers posted a request on how to make a PVC connector for his dust collection. In this video, I'll show you how easy it is to design this in Fusion. Since I am not 100% certain of the details of the desired design, I'm leaving specific detailed instructions on how to do this. The viewer indicated he does have Fusion on his computer, and he can literally draw this connector in less time than watching this video once he gets used to using Fusion. Let's open Fusion, and before I get into the design, I want to mention the new intent-driven workflow introduced in January 2026. With this change, AutoCAD renamed components to part, which is much easier to understand and also conforms with other CAD software. I'm not going into great detail on this, as there are excellent videos already on this subject, but very briefly, choose part if your design only contains one item. If you need multiple items, choose hybrid, which is the same design format as the previous Fusion versions, except the component is called part. For really complex designs, create the individual parts and then use the assembly design mode to put all those parts together. For this simple project, only one part is needed, so I select part design. My background is in aviation, so I make checklists for everything to keep it organized. I posted my updated version here. As time permits, I will update my other postings. Step 1 on the checklist is name and save the file. I will call it vacuum connector. Step 2 is setting the design units. As you can see here, it's already set to millimeter. Step 3 should be ignored for part design. Step 4 is choosing the view. I typically use the top view, but you can use whatever you like. We're going to spend a little time on step 5, which is setting parameters. If you get used to doing this, you'll be amazed at how much time it'll save you going forward. Few designs are perfect until you test them. By having parameters, you can make changes in seconds. I use it every time, so I set a custom shortcut to Control-Shift-P. I'm just gonna add the parameters fairly quickly here, as you will see how they're used when I design the part. Step 6, saving the file, should be done frequently to avoid extra work. Now we'll design the part. Click C for circle. Select the top view plane. Use the design center for the center of the circle. We will use the parameter called OD2 for outer diameter 2. This is the 110 millimeter end of the part. Click Fit to see the whole thing. Now press E for extrude. Use the parameter height 1, which is 50 millimeter. Now rotate your new cylinder to verify what you did. That's Shift scroll wheel. To make the divider, press C again for circle. Choose the top of the new cylinder and use the center point. This parameter is OD divider, or 120 millimeters. Rotate the cylinder again and press E for extrude. Select both the inner and outer circles and use parameter height divider, or 4 millimeters. Press Enter. For the other end of the part, press C for circle, use the top of the part and the center point, and use parameter OD1, which is 100 millimeter. Press E for extrude and again use height 1 as the parameter, or 50 millimeters, and then press Enter. It is time to hollow out the part. We use the shell command. Select both the top and the bottom of the part and use the parameter thick, which is 2 millimeters. Press Enter. To get the part back fully in view, just press Home as the view. Now I'm going to show you a simple way to strengthen the part. Close the name views and select Section Analysis. If you don't have it on your toolbar, you can find it by clicking on Inspect. Select one of the vertical axes. Either one will work. Click OK. One of the advantages of Fusion is that you can continue designing in the section view. Notice how the section view is also automatically added to your browser. Look at the divider area. This is a weak design likely to break. I want to add a chamfer here. You can use the chamfer tool, or you can simply draw a triangle. Press L for line and draw the triangle while making sure you place the endpoints on the part walls. To zoom in, scroll with the mouse wheel. Press Enter. If you end up with extra lines like I'm doing here, select it and delete it. Click Finish Sketch. Let's select the home view again. Use the sweep function and choose the small triangular area. Now select Profile and click on the inside perimeter. Choose Join if not already selected, and then click OK. To show you that this worked on the entire part, click on Section Analysis again and select the other vertical plane. Looks good to me. Click Cancel and then deselect Analysis in the browser to close the section view. Now I'm going to show you the power of parameters. We want smooth edges so fillets can be used. I set the fillet parameter to 2 millimeters. Let me show you that this is too large, what happens, and how easy it is to fix with parameters. As soon as I click OK, the whole thing collapses because the fillet is equal to or greater than the thickness. Definitely not what we intended. But all I have to do now is to open the parameter screen. Then I can change the fillet size to 1 millimeter. Since the fillet is applied both to the inside and the outside, this is a complete round off of the ends and nice smooth edges to the divider. It's fixed. Time to save the design. Hit Ctrl S. The last thing to do now is to get it ready for 3D printing. There are a couple of ways. One is to export the file in a printable format, whatever format you desire. The other way is send it to the printer directly. Right-click on your name design and choose Save as Mesh. Choose Print Utility and then select your printer software. I use Bamboo Studio. When you click OK, it will open your printer software. disregard the update screen that popped up here. I obviously have a pending update. Once the design loads, place it correctly for printing. This particular design may need support, but that's a separate subject. We are basically done. I am fortunate to own almost every tool you might think of. My 3D printer has become one of the best tools ever. And when you combine it with a powerful design program like Fusion, the possibilities are endless. I design or repair something every week with my 3D plastic gadgets, and it's often something you cannot buy. I hope this video helped you or motivated you to design something that's useful in your life. I appreciate it if you take the time to comment below about any future videos you would like to see. Thanks for watching.